Then there is this number 11A. It is a partial fraction question.
I think you are forgetting the partial
I
fraction.
don't understand the denominator because it has a square. And what I checked in my note, what I saw in my notes is different from what I know how to do.
I explained it. It's in your lesson notes. We did a lot of questions on that. But we'll get there. I'll explain to you again very quickly when we get to that. Write this very quickly. Once you know the rules. Oh, beautiful. You were right as I was going. That's good. Now let's go to the next one. We already did number 9. I think we finished number. Oh, beautiful. We're going to the number 11. We've done numbers 9 and 10, right?
Yes, sir. That's number 11.
Number
the
11.
Square denominator.
Number 11A. What's the compound fraction? 8x squared plus what? 8x squared plus what?
8x. X minus 1, 2x plus 3 squared.
Now, this is listen and and do so attentively. I'm just going to go over the rules quickly.
So let me tell you what you just need to tell me. I understand this. I just need one thing. You separate it into A over this, B over that plus C over that.
Hold on. Everything your question is going to be in my explanation. There are different types of factors. The factor can be linear. This is a linear factor. Do you know? A linear factor is of this form. It can be quadratic, ax squared plus bx plus c. Exactly. It can be cubic or anything. It can be a repeated linear. Whenever the power of the linear factor is greater than 1, you call it a repeated factor. Do you understand?
Yes, sir.
Here it's the same as saying it is raised to power 1.
Yes, sir.
Or if it is raised to a power that's greater than 1, then you say it's a repeated factor. Exactly. Now, what's the rule? If the denominator is a linear factor, the numerator of its partial fraction is going to have a constant. A constant is a polynomial of degree 0. The degree of the numerator is always 1 less than the degree of the denominator. The degree of the numerator is always 1 less than the degree of the denominator. The degree of the denominator here is 1 because it's a linear factor. N is 1. The numerator of its partial fraction is going to be a constant. A, if you just write A, that's a constant. It's going to be A over AX plus B. Exactly. So if this denominator, this factor is x minus 1, that's why you can just say A over x minus 1. But look at this second factor. What's the second factor? What's the degree of this second factor?
2.
Yes, it's n equals 2. Degree is 2. So the numerator of its partial fraction will be of degree 1. And a polynomial of degree 1 is a linear factor. Do you know that? It's a linear expression. So that means if you are writing this one, the partial fraction for this one, the denominator is a polynomial of degree 2, ax squared plus bx plus c. The numerator will now be ax plus b. This is the most general form of a linear polynomial, or a polynomial of degree 1. Exactly. Now look at this one. This one, don't mind this power. This could be 4x plus 7. If you square it, you know that it's going to be quadratic. But you don't see the denominator as something that will become quadratic when you square it. You just check the factor itself, ignoring the power. Do you understand?
Yes.
If you check the factor itself, you see that it's linear. So its denominator of its partial fraction will be a polynomial of degree 0, and that's a constant. So you can say A over, that's why you should say A over 4x plus 7 raised to power 1. This power 2 will just mean it is repeated. That means it will have 2 partial fractions. B over 4x plus 7 raised to power 2.
So, but why do you have to put the raised to power 1 and raised to power 2?
No, it's not compulsory. I was just doing that to explain. I just wanted to understand.
Oh, so you don't need to put raised to power 2 or raised to power. What about the raised to power 2?
You must put that now. It is repeated. If this is 3, there will be 3 partial fractions. So the first one will be raised to power 1, the second will be raised to power 2, and the third will be raised to power 3. The one for raised to power 1 is not necessary. The power 1 is not necessary now.
Yes, sir.
And you now expand. It can even be a quadratic factor that is repeated. If the denominator, the factor is this, look at this. 2x plus.
So when you want to write the LCM, how are you going to write the LCM?
We should say that in this solution. Look at this. We cannot factorize this quadratic factor now. if I say it is raised to power 2, that means there are going to be two partial fractions for it. The first one is ax plus b. When it is quadratic, the numerator will be linear, exactly, over 2x squared plus 11x plus 9. And the second one will be, you already used a and b, that will be cx plus d over 2x squared plus 11x plus 9 raised to power 2. Do you understand?
Yes.
If you know what you can do if you want to kill the partial fractions phobia, just solve all of the 60 questions in your project 1. If you cannot do all the 60, do the last 10 of each exercise. I think there are about 3 exercises. Do the last 10 of each. If you're able to do all of those, I don't think there's any question why I could ask you on it that you'll not be able to do. So let's go back to the question. Yeah.
How we go back? So I checked all those. What's that topic? Differentiation and whatever. But I don't understand the implicit differentiation.
We did that now.
Yes, sir.
We did that. Hey, don't worry, we're doing it. We're going to go over it again by God's grace in the course of this revision. Implicit differentiation is simple now. I'm going to show you maybe when we finish. Maybe some other time at our next meeting or sometime. It's simple. Implicit differentiation is simple. So now this is going to be, the first factor is linear and it is not repeated. Do you know? So
Yes.
that's a over the numerator of the linear factor is going to be a constant. That's
X
a. X minus 1 plus the second factor is also linear, but it is repeated. So it will have two partial fractions.
2x plus 3 raised to power 1.
3. We don't need to put the raised to power 1.
Plus c over 2x plus 3 raised to power 2.
Raised to power 2. Beautiful. Now, what's the LCM of all of those denominators?
X minus 1 into then 2x plus 3. Are you meant to write this power 2? Or you write
raised to power 2 is better. No, raised to power 2 is better. So now, when you divide the denominator by... Say that again.
Can I continue?
Okay, yeah. You want to continue here and have me write, or you want to continue your notes?
I want to continue from here.
Okay. Yeah, you write on.
Okay, so I just do the LCM part, the upper part.
And now you divide this LCM by x minus 1, you'll be left with the square of 2x plus 1 plus b into brackets. When you divide this LCM by 2x plus 3, what are you going to be left with?
X minus 1. Sorry, x minus 1, then 2x plus 3 also.
Beautiful. Okay. And finally, when you divide the LCM by the square of 2x plus 3, what are you going to be left with?
X minus 1.
I think you can find a way to just write as I write. I get bored.
I'm writing as you are writing.
Good. So what do we now do? I think I'll go by this approach so that you get confused. I want to use the comparing coefficients method. Exactly.
The one that you equate the two numerators.
No, what this simply means is that the denominators are the same. Denominator here is the same as denominator here. So that means you can equate the numerators. So that means 8x squared
plus 8x plus
9 equals a into brackets the square of 2x plus 3 plus, I want to write on the next line, b into x minus 1 2x plus 3 plus c times x minus 1. Now let's expand so that we can use the comparing coefficients method. There's an easier approach, but I don't want you to get confused. So let's do that. When you expand the right hand side, what do you have? What is the square of 2x plus 3?
Square of 2x plus 3.
Yeah.
That's 4x plus 9. Do that
in a rough of paper and tell me the answer. Oh, God of mercy. Do you know that the very, very first thing to do before you start resolving a fraction into partial fraction
4x is plus 12x plus 9.
No, 4x squared now.
Oh, sorry. 4x squared plus 12x plus 9.
It is 12x plus 9. That's correct. Ajara, before you resolve any fraction into partial fractions, you must check whether it is a proper fraction or an improper fraction. How do you
Yes,
how do
I
you
remember
check
that.
whether it's proper? How do you check whether it's proper or
The
improper?
degree, if the
Of the
degree of the
numerator
numerator is
must be
greater
less
than
than
that
that of
of
the
the
denominator.
denominator, it is
The
normal.
degree of the denominator must be greater than that of the numerator.
Yes.
Exactly. You can say that if you expand this one, you get x cubed. This one will give you x squared. When you multiply by this x, you get x cubed. But the numerator has x squared. So the degree of the numerator is
That's
2, therefore
proper.
the denominator is 3. So that means it's proper. But if the degree of the numerator is the same as that of the denominator, or it is greater than that of the denominator, it's an improper fraction. And you have to divide before you resolve into partial fractions. You can even check, I don't know, if you check by channel, you find the solution to that question, those questions you sent me. One of those videos on partial fractions has exactly those questions, I'm sure. Now, so plus what? What is x minus 1 times 2x plus 3?
So we have to open all the brackets.
Yes, now I want to use the method of comparing coefficients. There's another approach. I'm going to use it too so that you can choose for yourself which one you prefer. But I'm using this one because I feel that you need to learn a method, get used to a
That's
method.
2x squared plus x minus 3.
Are you sure?
Yes, sir. You
That's
can't change.
2x squared plus 3x minus 2x. Yeah, that's correct. Now, what's the last one?
That's all. You don't need to.
Plus
There's nothing to
cx
see x
minus c
minus
now.
3.
But don't let me open it here. Let me just write as c into x minus 1. So we now go to the next step to open. What do we have when we open? 8x squared plus 8x plus 9 equals, let's open the brackets now. 8 times 4x squared is 4ax squared.
4x squared a. Can you write
No, you
4x
write
squared
4.
a?
No. You arrange alphabetically. And by the
4ax
way, a is a
squared
constant. And that's what? 12ax plus what?
plus 9a
Plus 9a. What's
plus
the next one?
2bx squared plus bx
Beautiful.
minus 3b
Beautiful. And what's the next?
plus 3x minus c.
Cx minus c. Now, this is what I want to do. I want to compare, what's it called? The coefficient of x squared. Take care. Comparing the coefficients of what do we say?
Of a constant.
No, of x squared first. Let me start from x squared. What's the coefficient of x squared on the left hand side?
8.
8. Right hand side?
4 plus 2.
No, 4a now.
4a plus 2b. 4a plus 2b.
So I can say 4a plus 2b equals 8. If you like to simplify the fraction, divide both sides, divide through by 2, and then you have 2a plus b equals 4. That's equation 1. Comparing the coefficient of what do we say now?
X.
Is there an I after the a in comparing? Is that spelling correct?
So, comparing. No, there's no. This is COMPA.
Okay. Are you sure? Are you sure you're not a bad speller?
You can check.
All right. Compare the coefficients of x. What do we have?
8
I'm doing the right hand
equals
side first, so that I don't have to rewrite the equation.
8 equals 12a plus
Let me write 12a plus.
b plus c.
Let's see then. 12a plus b. You have to be careful. Plus c equals 8. Exactly.
Can you divide both sides by 4?
No, it's not common to all of them.
Oh, yes.
So what's the next? Comparing
Like
the coefficients of x.
of a.
No, comparing the constants now.
Comparing the. What about the coefficients of the constants?
No, there's no coefficient of constants, and constants are constants.
Okay, so 9a is a constant.
Yeah, it's just a constant. Ajara, hold on a sec. If you check one side and there's no x squared term, then you say 0 is its coefficient. Do you understand?
Yes.
If, for example, there was no x squared term on the left hand, I would have said is equal to 0 instead of saying is equal to 8. So comparing the constants, what are the constants on the right hand side?
9. Right hand
Not,
O.
not
9A
9a, 9a minus 3b.
plus
9a
9A
minus
minus
3b
3B
minus c.
minus C
Minus c. Can
equals
you see
9.
that last? Yeah, 9a minus 3b minus c equals 9. And that's equation 3. How do you solve all of these equations? How do you solve these equations?
You pick one. You start solving. You solve 2 at first, then I'll find a little bit. You solve the
You
2A
know,
plus the ones that have A and B first.
no, your substitution is better. Make one of the unknowns the subject of one of the equations and put it in the remaining two.
That was
So I
what I
want to
said the
make B
last
the
time. You said
subject.
elimination is better.
No. Here you have to do substitution before elimination. You know there are 3 equations.
Yes,
So I have to use substitution to make at least 2 of them the same. And then you can now solve what's it called? The 2 equations. So from equation 1,
A equals 4 minus B over 2.
no, that will be clumsy. Now avoid fractions. B is 4 minus 2a. Do you understand? Do you understand? It's better to avoid fractions. Putting b in 2. When you put b into, what do you have?
I'm coming.
12a plus. I'm going ahead of you, and I hope you
Plus
get
4 minus 2A plus C equals 8.
I don't even need to put this in bracket. I think it's just 4 minus 2a. So what does that mean?
So I also put this in bracket.
Whether you do the same, so that's 10a
10A
plus c
plus
equals 8
C
minus
equals
4.
8 minus 4. That's 4.
10a plus c equals 4. That becomes equation 4. Now putting b in which other equation?
Equation 3.
We got it from, obtained it from equation 1, so we're putting it in 2 and 3. What's equation 3? 9a.
9A minus 3.
That's 3 into 4 minus what?
4 minus 2A
Uh-huh.
minus C equals 9.
9. So what do we have? 9a
9A minus 12 plus 6A minus C equals 9.
Beautiful. Plus 6a minus c equals 9.
15A equals 9 plus 12. 15A equals 21.
No, now 15a minus c equals 9 plus 12. Don't be ahead of yourself. Take the 12 there and write it as plus 12. If you are being too fast, you are going to make mistakes. And what equation would that be?
Equation 5.
So what do you see? You notice that 5 and 4 are, in the same terms, so we can solve them simultaneously. So 10a plus c equals 4.
15A.
And then 15a minus c equals 21. What do? We can already eliminate the c. How?
Subtract.
When signs are different, how do you eliminate?
Add.
So 10a plus 15a, when signs are the same, you subtract to eliminate. 15a, this will be out, equals what? 25, right?
Yes.
And what's a? If you like.
A is 1.
Beautiful. A equals 1. So what do? You can put a in
Equation 1.
wherever. No, equation 1 has more than 2 terms. You are putting it in an equation that has only a and an unknown. Putting
This
a
is
in 4. Okay, so what do we have?
10 plus C equals 4. C
10 into
equals
bracket 1. No, you should write it as 10 into bracket 1 plus c equals 4. And then say c, exactly. 10
minus
equals 4. C equals 4. Don't be ahead of yourself, exactly. There are no marks for you knowing it and missing it. They won't pardon you. because you missed it out of an error. So now we already have A and C. There's a definition for B already. That was even the first one we should find. We were supposed to find B equals 4 minus 2A. And that's 4 minus 2 times 1. Do you understand?
Yes, sir.
And that's what?
4
That's
minus
2.
that's 2.
You like 4 minus 2 first, which is 2. So we have all of them. A equals what? 1. B equals what?
Minus 2.
C is what? Minus 6. So therefore, I hope you are not bewildered. You don't pretend as if you are getting it if you are not getting it.
I'm getting it.
Okay, alhamdulillah. X minus
So if
1.
we use the other method, will you get the same answer?
The other method is a bit simpler. I'll show you that. Let me show you. So that you now decide which one is better. It's a smarter, approach. That's A over X minus 1. That's 1 over equals 1 over X minus 1 plus B over 2X minus 3. That's 2 over 2X plus 3 plus C, which is minus, plus minus 6, same as minus 6 over. Hello?
Yes, sir.
Yeah, that's it.